In the previous video, we dealt with triggers in general. Perhaps you have already assigned templates to your hosts, so you have a large number of triggers configured by now. After a few days of working with Zabbix and getting your first alerts, you may discover that a single problem leads to several triggers firing. So in this video, I want to show you a way to avoid getting spammed by alert messages. Let's take a look at a typical scenario. I have 3 web servers configured, 1, 2, and 3, and I have a network switch called switch 01. The web servers are connected to the switch, and I have added an ICMP ping item that is sending 3 ping requests to the server and checks whether it replies. And I have also added a trigger to check if the ICMP ping was successful. Let's assume that the network switch suddenly fails, and my Zabbix server won't be able to reach the web servers anymore, because they are connected to that switch. Zabbix will fire all these ICMP ping triggers, and I will get 4 alert messages on my cell phone. However, the web servers are probably still running. The actual cause is the failed network switch. This may look like a small problem, but imagine having 100 servers so that such an outage will send you 100 messages. And that's where things stop being funny. We can solve this problem by using trigger dependencies. We need to tell Zabbix that the operation of the web servers depends on the proper function of the network switch. So let me change the triggers that send a ping request to the web servers to determine whether they are available. I could do that manually for every web server, or even use a template that is specific to my web servers. But I will just do a mass update on the triggers. I choose to set the dependency. And I select the ping fail trigger from the network switch. I click on Save, and now you can see the dependency. Now let's try again and see what happens. I'm pulling the cable from my network switch, and this time you see that only the switch failure is alerted. The arrow icon tells us that there is a dependency in place. When I hover over the icon, Zabbix tells me that there are 3 more problems that were hidden by the dependency. You can also see the dependency when you go to the overview and hover your mouse over the red box. Let me give you an important hint on trigger dependencies though. They only work correctly if the trigger that you depend on can fire earlier than the other triggers. The current example can easily lead to a race condition if first the web server is found unreachable and then Zabbix checks the switch. That would send out alerts instantly before Zabbix has a chance to resolve the dependencies. One solution would be to use an escalation in your alert workflow that waits a minute before sending out the first alert. Or you could change the web server's triggers to only fire if multiple attempts to reach them would fail. The switch is checked every 30 seconds, and the first failure would fire the trigger. So let's change the triggers on the web servers to fire only if ICMP replies are missing for at least 1 minute. So I'm changing the trigger expression to count #2,0 greater than 1. This function does not only take the latest value into account, but rather it counts how often the result was 0 in the last 2 readings. If the last 2 results were indeed 0, then the trigger fires. This gives Zabbix enough time to check the switch first and resolve the dependencies properly. That concludes this video. You learned that trigger dependencies can help you avoid wrong alerts when central parts of your network infrastructure fail. You saw how to set up dependencies and how situations with dependencies are displayed in the overview.